Alright, so we're gonna move to log properties day 2, so title that for your notes. And as we do this, let's just first of all review a little bit about yesterday, okay? So the directions are gonna be express as a log of a single number. And a review from yesterday would be if I told you 5 log base 4a plus log base 4b. And the property we talked about yesterday is plus means you multiply, right? And if you have a number in front, it turns into an exponent. So, and this step I'm about to write right now, you don't have to write down, it's just good for your notes. But this is the same then as log base 4 of a to the 5th power. Isn't that the same? Okay. Plus log base 4b. And now because I have multiplication, it means you're going to multiply the a to the 5th and the b together. So then that means your answer is log base 4 a to the 5th b. Notice I went from expanded form here, it's really long, to a single log. Do you see the directions? Express a log as a single number. So it was from expanded form to condensed, a single log. Right? Number 2, 4 log base 5 of x plus, no, I'm sorry, let's do minus this time. So minus 1/2 log base 5 of y. This problem, okay, you have a subtraction problem, and again, the 4 becomes the exponent here, and the 1/2 becomes the exponent here, right? And it is subtraction, so we're going to turn it into what? Division. Okay, so then we're going to write log base 5, and this is actually x to the 4th power, divided by y to the what? 1/2 power, or you can even write it as the square root of y. That's kind of the more accepted way. And then that's the answer. Remember, subtraction means division. All right, so those 2 problems are review. So here's the 2 problems today that are new. Number 3. If I asked for log base 2m plus log base 2n plus 3. Okay, you know that little song, you know they sing, I think, on Sesame Street, which one of these is not like the other?
I thought you couldn't have like a radical and dividend.
Correct, and if you were going to simplify it, you would.
Okay.
But for just for the simplicity of putting in the log, it's okay.
Okay.
That little, you know, which one of these is not like the other, right? For here, which one of these doesn't match? The what? The 3, correct? So I've got a log base 2, and for my property to work, I need a log base 2, a log base 2, and I need another log base 2. So if you have a whole number, okay, you're going to need to put this must be in log form. This must be in log form, guys. All right? So what log form do I want? I want it to be what? I'm going to rewrite it as log, what base do I need for it to fit in? Log base 2, right? And I want it to equal 3. Okay, if I want it to equal 3, let's think about what this means. If I want a log to equal 3, then that means 3 is my what? 3 is my exponent. Good. Okay, so what exponent? So here's what you can do if you want. I want log base 2 something, and you can put yourself like an imaginary circle there. I want it to equal 3. Isn't that what I want? Are y'all see what I'm saying? I know that this 3 needs to say log base 2. And I also know that because I'm replacing it for 3, whatever I put here has to have the value. It has to equal 3. Okay, how can we figure out what number is there? 2 to the third power, right? You can do circle math. 2 to the third power should land me with what? What goes there? An 8. Because isn't log base 2, 8 the same thing as 3? So then what you have now is log base 2m plus log base 2n. And I rewrote 3 in the form of a log. I'll repeat myself again. So I want to write log. I need it to be base 2, right? And what number goes right here so that has a value of 3? The number 8. And now it says add, so I'm going to multiply the m, the n, and the 8, all of them together, right? Well, when you have an m, n, and 8, the 8 always leads, right, in proper form. So it's going to be 8mn is your answer. That's in one log. Okay, let's see if you really understood that. We'll try another one. Here's number 4. Log base log base 3. Log base 3a minus log base 3b plus 2. Which one doesn't fit in? Why, I can't use order of ops. I can't use my properties unless they all have the same base. So we're going to replace 2. You must put it in log form. This must be in log form. So I'm going to write log base 3. This is log base 3 and this is log base 3. And what does it have to equal? Whatever I place this with has to equal what value? Has to equal 2. Correct? So if I do circle math, what number am I going to put right there in that spot? 3 squared is 9. Okay. Yeah, there's a plus there. Now then, so what I have, and if you rewrite this, and that's up to you, is log base A minus log base 3b plus log base 3,9. Because this has the same value as 2, right? Log base 3,9 is a value of 2. Now, when you are subtracting, when you're adding and subtracting, order of operations says you don't do addition and then subtraction. Order of operations says you have to do left to right, correct? If it's addition and subtraction. So you're going to solve left to right. So you're going to do this part first. So I have log base 3 of A divided by B. And then what am I going to multiply that by? I'm going to multiply this by 9. So times 9, or like times 9 over 1. Do you agree? Because we have a fraction there. So then that becomes log base 3 of 9a over b. Okay, so now we're going to do a little bit more review of yesterday still. The directions. He's asking for the answer. Log base 3, 9a over b was the answer to number 4. Okay, so the directions for the next part are just simplify. So for number 1, we have 2 log base 10 of 5 plus log base 10 of 4. And this one again, just a little bit of a review, trying to be sure you're getting better and better at logs. Remember the property yesterday, if you have a number in front of the log, it turns into the exponent. So this becomes the exponent. Now I'm going to write down this step because it's notes, but this is not required, okay, this step. So that's what it means, doesn't it? Some of you can do that part in your head. So now since it's plus, the property says you can multiply the 5 squared and the 4 together. So 25 times 4 would be 100. So log base 10 of 100. what is the log there? How do I get from 10 to 100? So what's the log? What's the exponent? 2. Good. Okay, number 2. Log base 3 of 4 minus log base 3 of 324. It's subtraction, so we are going to do what? Divide. The bases are the same and it's subtraction, and the property says you can divide. Log base 3, the first number is the numerator. Okay, then you're gonna try to reduce that. I know you don't have a calculator, so if you think about your divisibility rules to see if it'll even divide. Okay, first of all, they're both even, so I know 2 goes in. But if you wanna think about 4, 4 fits in, the rule for 4 is check the last 2 digits. 4 fits into 24, right? So 4 fits into 324. The divisibility rule for 4 is check the last 2 digits. Okay, so if you'll check it, it goes in how many times? 81 times. So then that means you have log base 3 of 1 over 81. What exponent gets me from 3 to 1 over 81? Okay, I know you don't like the fractions, so think about it. What gets me from just 3 to 81? 3 to what power is 81?
27.
3 to what power is 81? 4. But the 81's in the bottom, so what's the actual answer? -1. Remember, the answer to a log is an exponent. So 3 to the -4 power is 1 over 81. Okay. Now then, next thing we're going to talk about, okay, is one last property. Right? So let's talk about a property. Your new property is called the property of equality. Property of equality. Okay, I'm going to write down a bunch of letters, the formal property is what I'm going to write, and then I'll explain it. So what the property says is that if you have log base b of x1, it's the same as log base b of x2. And I think this property is actually kind of cool. It makes logs really easy, right? So let me explain in like real numbers what I'm talking about. If I told you that log base 2 of 8, okay? What is that answer, by the way? What's a log if you have base 2 to 8? How do you get from 2 to 8? Right, the answer is 3, okay? So I know this value is 3. Now this is a really simple version of this, okay? Because I'm trying to explain the property to you. It's a property, it's a rule, it always works, right? Okay, just like 3 times 4 is the same as 4 times 3. Now, so if I say this, then I give you log base 2 of x. Now, let me ask you just a simple question here for a second. This value you just told me is 3, correct? And if I'm saying the left side equals the right side, what's the value of the right side? I'm telling you they're equal. So what's the value over here? 3 must equal what? 3, right? This is really simple. Don't make it harder than it is. I'm trying to show you a real basic problem here. So 3 equals 3. Well, if that's the case, I know to get from 2 to 8 out of power of 3. So what value has to be right here? If this value is also 3, what does x have to be? It has to be 8. Okay, and since you're watching this, and that means I'm going to, you don't need to necessarily do it on your notes, but I'm going to show you that. That means I'm going to replace what was x, right, okay, with an 8. I'm going to replace x with 8, right? So then what does that tell you? If I erase that again, what does x have to be then? What is x? 8. So what is really cool that happens is that if this is log base 2 and this is log base 2, the property that works, what just happens? If this is log 2 and this is log 2, then this answer here and this answer here are equal. Okay? Right, and the reason is because I'm asking you for an exponent, right? If the exponent to get from 2 to 8 is 3, then to get from 2 to whatever number is also 3, that better be the same value. Okay? It's kind of like in simplistic term, if I told you x plus 2 equals x plus some number, what does that some number have to be? 2. Same here. Okay? So let me give you another problem like it. It's a very basic one. Here we go. If I say log base 3 of x equals log base 3 of 4. Now this is a real simple problem. So look at it for a second. If I'm telling you that the exponent to get from 3 to 4 is equal to this side, then the exponent to get from 3 to something, what does x have to be then? If these are the same, they have to match, don't they? So what does x have to be right here? 4. Now I know this is really basic in this part. That means that this value equals this value, but it only works, the property only works if the logs have the same base. Okay? So then that means x will equal 4. All right, one more problem like that, just to show you. If I say log base 4 of 3x minus 1 equals log base 4 of 2x plus 3. Right? What's the cool trick that works? I know this is more complicated, but it doesn't make the rule change. Okay, the rule says that if this is log base 4 and this is log base 4, and I tell you that they're equal to each other, then it means these cancel, right? And it means that 3x minus 1 equals 2x plus 3. So let's solve for x. Move the 2x over, so it gives you x minus 1 equals 3. Move the 1 over, so x is 4. And you can test it if you want. Look for a second. I have log base 4, and I plug in 4. 3 times 4 is 12, minus 1 is 11. Log base 4 to 11 equals, here I've got log base 4. If I plug in 4, 8 plus 3 is 11. Do those equal each other? Yes, so it worked. I'm not going to make you check it every time. I was just showing you. Okay, so let's try another one then. You kind of get the concept. We'll move on. Here's just the directions to solve. Number 1, log base 5 of 5x minus 2 equals log base 5 of 2x squared. What does the property say? Property says that if you set 2 logs equal to each other, right, that the logs cancel and that the numbers here are equal to each other. So 5x minus 2 equals 2x squared. This is just a quadratic now, right? If you have a quadratic, we've studied that, a whole unit worth of quadratics. What do? If I'm going to solve for x, I move everything over. So I'm going to say 0 equals, I'm going to move the 2 and the 5x. So 2x squared minus 5x plus 2. And then you have to factor it. So 0 equals 2x minus 1 and x minus 2. So x is 1/2 and 2. 2 values work for x here because of the square. Okay, so now we'll move to number 2. I'm going to